Last type of equation and graph to talk about are called Limacons or Limacons, depending on where you go. And these are actually very similar to what we had when we did the cardioids, except with Limacons, sometimes Limacons don't have a little divot like the last one is, or like a little sharp point. Instead, Limacons either form a loop, and that loop happens if the K number that's all alone is smaller than the C number. If that's reversed, if the K number is bigger, then instead of coming around and looping, it never quite gets all the way back to 0 like we saw with the cardioid. So it just kind of goes, and there's like a little bit of a dimple, but it's not like a full sharp point like we saw with the cardioids. And then cosine always kind of runs along the x-axis, and if you have a plus, it's going to be to the right. If it's a negative, it's to the left. If you're looking at a sine graph, that always runs along the y-axis. Positive would be up, and negative would be down. And so, I kind of in the other video talked about how you can plot points kind of roughly just by knowing some things. We can also actually plug in those same 4 coordinates and then connect with a smooth curve. So if we look at our first one here, we have 2 plus 5 times the cosine of theta. If we were to plug in those coordinates, I would have 2 plus 5 times the cosine of 0. But the cosine of 0 is 1. So that would be, and 5 times 1 is 5. So 2 plus 5 gives me 7. So if I'm going, when I'm facing 0, I would go out 1, 2, 3, 4, 5, 6, 7 steps and plot my point. And when I go plug in 90, I will have 2 plus 5 cos 90. But the cosine of 90 is 0 degrees. And 5 times 0 is nothing. 2 plus 0 gives me 2. So when I'm facing up, I'm only going 2. Whoops. I want that out there. 1, 2 spaces away for that second dot. Next I have 2 plus 5 cosine of 180. The cosine of 80 is negative 1. So here's where things are a little bit weird. So now that gives me 2 plus 5 times negative 1, which would be 2 minus 5, which is negative 3. So where this is a little bit weird is I'm facing 180, but I'm walking backwards 3 steps, which puts me on that side of the 0 again. And then I'll plot my last point, 2 plus 5 times the cosine of 270. The cosine of 270 is 0 though, so it's really 2 plus 5 times 0, which is 2. So when I'm facing down to 270, I'm plotting a point at 2 units away. So then to sketch this, I have a smooth curve again, and since this 2 is less than 5, I'm going to have a loop. And the reason I ended up with this negative value is because of that loop. So when you draw this one, what ends up happening is we start over here, we have a big nice smooth curve, but then we get a loop that touches that point before coming back out and around. I'm going to try that one more time. So big smooth curve as best as you can. And then we have our loop. Again, if you get those 4 points plotted there, and you have generally a smooth curve, and I can see that loop there, that would be good enough. So let's try one more. Let's try another one here. So I'm going to plug in 0. I'll have 5. Whoops, switch to my pen. 5 plus 2 sine 0, and the sine of 0 is 0. So I end up with 5 plus 0, which is 5. So when I'm facing 0, I'm going out 5 units. When I'm facing 90, I'll have 5 plus 2 sine 90, and the sine of 90 is 1. So this will be 5 plus 2 times 1, which is 5 plus 2, which is 7. So when I'm facing 90 degrees, I'm all the way up at 7, right on the edge for this particular graph. Then for theta equals 180, I'm going to have 5 plus 2 sine 180, which gives me 5 plus 2, and the sine of 80 is 0. So I'm going to get 5 plus 0 again, which is 5. So when I'm facing 180, 5 steps. And then last but not least, I'll have 5 plus 2 sine of 270. And the sine of 270 is negative 1. So this time I end up with 5 minus 2, which is a positive number. And so the big difference, the reason we had the loop last time is that k number was smaller than c, and we ended up with a negative number here. When that k number is bigger than c, I end up with a positive number here. And so when I'm facing 270, I plot that point 3 units down. And so in this case, I don't have a sharp point like I did with cardioids, and I also didn't get that loop. So when I sketch this one, the only thing it shouldn't be like a circle. You should go a little bit past, and it should be like a little divot or a dimple, they sometimes call it. And then there. Oh, mine is really rough with this iPad drawing. Sorry. So around. Try last time. Around, dimple, around. Okay, and so I mentioned in the other video that you can kind of shortcut these. You can do that with this one too. What we would do with this is say, well, I have a sine graph that's positive, so my furthest away point is going to be up in that positive y direction, and you would add these numbers to tell you how far away it is. So 5 plus 2 gives me 7 units away. To figure out the point in the opposite direction, the negative sign direction, you subtract k minus c. 5 minus 2 gives me that 3. In the last problem, we had r equals 2 plus 5 sine theta. The way you would see that loop is now when you do k minus c, you'd end up with your negative 3. And so when you're plotting that point, you would face down, but you would go in the negative 3 direction. So the shortcuts work, and then on the sides, you're going out the k value. 2 points on the side are 5 to the right and 5 to the left. That's if you want to try and use that shortcut plotting, or at least for double checking. And then last but not least, we'll do one more here, and then we'll call it a wrap. We have 2 minus 4 sine theta. So if I do 2 minus 4 times the sine of 0, sine of 0 is 0. So we'll have 2 minus 4 times 0, which is just 2 minus 0. So when I'm facing 0, I go out 2 steps. When I plug in 90, sine of 90 is 1. So I end up with 2 minus 4, which is negative 2. So, we see a negative. Looks like we're going to have a loop. Does that make sense? Yeah, it does. When that number is smaller than, when that k value is smaller than that c, we should have a loop. So I got to be careful I plot this. When I'm facing 90, which is up, I should go backwards 2 steps. There's my point. Then next I'll have 2 minus 4 sine 180. The sine of 180 is 0, so I end up with 2 minus 0, which is 2, when I'm facing 180 degrees. And then last but not least, 270, if I take 2 minus 4 times the sine of 270, that gives me 2 minus 4, but the sine of 270 is negative 1. So I had a negative 1 times 4. What I technically end up with here is 2 minus negative 4, because 4 times negative 1 is negative 4, which ends up being 6. So when I'm facing 270, I need to go forward 1, 2, 3, 4, 5, 6, and then we have our Limacon with a loop, or our Limacon with a loop. So I draw my curve around, get my loop, and come back around. And again, that kind of shortcut way, you would say, well, this time I have a sine graph, so it's going to open on the y, but it's going to go in the negative direction. And my furthest point away is what I get when I add those two. 2 plus 4 gives me 6. My closer point, or my loop point, is what I get when I take 2 minus 4. So I'm facing up in that direction, and I go back, and that's where my negative 2 came from. And then this value is how far I go to the left and how far I go to the right, at least for a sine graph. So that'll wrap it up for Limacons.